Okay, example 2, this is section 1.5, example 2. We're going to find perimeter and circumference. It says perimeter, that means around the outside of a polygon. If it says circumference, that means around the outside of a circle. So we have to find one or the other. The area is the space inside. So we go to perimeter here, relatively easy. It's a basic plug and chug, or what we call in real mathematics substitution. So first we have to go get our formula. Our formula is twice the length plus twice the width for a rectangle. A rectangle is technically defined by a four-sided polygon with 4 right angles. We substitute in the values. Length and width are interchangeable. So if you plug in 2.1 for length, it's not wrong. Normally I do the longest side, or the horizontal side is length, but it does not matter. If we have something like this now, where it's just math, I don't say you have to show all your work and all your steps. You could plug that all directly into your calculator and it'll give you the answer. Now remember, perimeter is around the outside. It's like a string, so it's just length. It's not squares to cover. It's a length around the outside. So it is in whatever units it says. So we're talking centimeters, so it's just centimeters. To find the area of a quadrilateral or of a rectangle, you multiply length times width. That's from the formula sheet. Again, substitute in. Use your calculator. And now we're talking square units. Notice we did units times units. When we do times, centimeters times centimeters, we get centimeters squared. And area is how many square centimeters, how many squares does it take to cover it. Okay, if we were in class, I would show you where we get this number from. Now, I know you guys think this represents a number. It's the Greek alphabet, kind of like the letter P. You see them a lot in fraternities and sororities. It's normally where you see the Greek alphabet. That's kind of the Greek alphabet. It's kind of like the letter P, but we use this as a symbol just to say the relationship between the diameter to circumference. For any circle, if you take the diameter to the circumference, it takes 3 of those plus a little bit more to get around. But I think most of us know that pi equals 3.14. Now, in math, we try to keep pi as long as we can. If we don't need an actual number, I just, later on in higher level math, you will just leave it as pi. So my answer here, and later on math, the exact answer would be 6 pi. However, we are actually looking for distances here that we could use. So we're going to substitute in the value 3.14. Also, on your graphing calculator, it is second, and then the caret button, which is underneath the clear button. So you hit the second button, the blue button, and then you hit the up arrow, and that'll give you the blue function, which is pi. You could also just use 3.14 because we're only going to go to hundredths right now. We're going to round to the nearest hundredth. So remember, we're going around, so it's a string, so it's just the length, so it's one dimensional, so it is not squared. So it's 18.9 inches. Okay, and this is where I make my terrible dad joke. The biggest lie in mathematics, this formula right here. Area equals pi's r squared. Everybody knows pi's are round. Ha 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 ha. No. Area equals pi r squared is the formula. Again, basic substitution. R is 3. Make sure you follow the order of operations. You have to do this first. Your calculator will do it for you if you just plug it in. But if you do pi times 3, then squared, you're going to get the wrong answer. Now again, we're talking about area, so we're talking about how many squares does it take to cover the inside here. Any questions so far? It's kind of one of the easier ones, and because most of you probably already know this, they're basic substitutions.